Hey guys, so today's lesson is going to be all about inheritance. And that's not when you get a bunch of money from a rich uncle that dies. That is when you have a parent-child relationship between two classes. Inheritance. Always have a problem spelling this word. It's an A. Thank you, Eclipse. Okay, and with inheritance, we have a parent and we have a child. These are different classes. And the real name, what's going to be referred to in the textbook is the parent is usually called a superclass. That's the fancy word. And the child is called a subclass. And we're going to be doing a lot with this word extend. So you could say that a subclass extends the superclass. And that's actually the key word in Java that we're going to be using to make this relationship occur between classes. Okay, so I'm going to start with this example. And the thing that I was trying to do was I was thinking that, random, we've been using it to do stuff like get numbers and things. And then I was thinking that it might be useful to be able to also get random letters from it. So let's just show you how it works with the normally works without us adding anything. So usually we have this, we use this a lot next int, there's next boolean and next double. This is complaining now. That's the right. Oh, okay, so this is interesting. I'm glad we stumbled upon this. So actually what it's doing is I'm trying to use the random, which is part of the Java util package, but it thinks that I'm trying to instantiate my own random class. So that's why it's getting all angry at me here. So actually I'm going to rename my class because that's already one that's sort of taken. I'm going to do my refactoring to rename with my Control Alt and R, call it randomness. I should have read that, didn't read it, but anyway, why can't I call it randomness? Okay. And this, where I was really going with this was I was trying to do random dot next int, and now I've got to import random. Thank you. And I should get a number. All right, I got a number. Ooh, it's red. Yes. Hey, so check this out. See, with that error thing, I meant to do a CISO with just an out, but if you put it as an error, that means error, and then it will be red. System out. Okay, so what I was hoping we could make is this thing that lets you get next letter, but that doesn't exist in random. If you look at it, you can just get like ints and longs and doubles, and we were using it for booleans before. Yeah, boolean is a true or false. So let's try and see if we can make this next letter method. I could cheat and just use the quick fix to make it. Oh, okay, it's not giving me that option. I can do it. All right, so the return type is going to be a string or a character. Maybe I'll change that in a minute. I'm going to, why does it not like that? Okay. Yeah, I gotta have it return a string. So I'm just gonna have it return an empty string for now so that it stops being read. Like that. Okay, so the thing is, there's this random in Java, and I've got my own class, random, that I want to use all of the existing methods that are in random, and then I also want to add this next letter class. So what I'm going to do up here is I'm going to have my randomness extend random. Okay, so over here, I'm just going to control space. There. I'm going to control space after random and see that you can get all of the things that we're used to seeing, all that. And now I'm going to have it add this next letter class, so method. So randomness is going to have all of the regular stuff. And then it's also going to have this new thing, next letter. That's my own special thing. So if I wanted to use this class later, I could use randomness. and then I would get the extra stuff. I'm actually going to rename it to extra random. Okay, so let's think about how we want to implement this. So we want a letter of the alphabet. So, random number between 1 and 26 letters. Okay, that's a number. There's this thing that we have. So there's characters in Java. Characters are primitive type. You're not using your capital C there. And you declare them like this with quotes, a single quotes. So that's a car. And in here you can have letters, and you can also have like symbols and then all sorts of crazy stuff. I just care about the letters for now. But the other thing is these actually are represented as numbers inside the computer, so you can cast it to an int and then get its number value. Okay, so that's a cast. What this is going to do is it's going to take my character here. I'll make it A, and then it's going to convert it to an int and print it out. Okay, so what this is telling me is that the character A has the int value 97. So now I know I actually want to get a random number between 97 and 97 and 26. Is that 26? Yeah, 123, something like that. All right, let's see if we can do that then. So what I'm going to do is get that random number, cast the random number to char, and then return it. Okay, so let's do this randomness business. That car was just so I could show you guys how you declare them. Some people call them chars, cars. I don't really mind. Interchangeable. Okay, so for this we're going to use the regular old random. Random. Next int. Okay, now this, as we just saw, is going to give a very large number, so I want to bound it. I want to bound it by 123. That's the top that I want. And then the bottom is going to be 97. Yeah, okay, so that looks good. And then let's take our rando and then cast it to an int and return it. Car random car equals that stuff. Oh, silly me. I'm actually trying to... Okay, int. Yes, I do want to convert it to a car. It should be this way. Char. There. Return my random car. I'm not sure if it's going to stay like this, but let's see. Print it out there. Let's see what kind of things we're getting. Oh, an I, a D. That weird thing. I feel like it's not giving me A's and things, so I'm just going to print this out and see what kind of values we're getting for rando. And there's a nice U. 210. Okay, this is not right. This should start at 97 and go to, I guess it's 123 minus 97. Okay, so I'm looking at this now and I'm not really comfortable to knowing if I've got all of the random, if I've got like the whole alphabet in here. So I'm going to go over and write a unit test. Now, I didn't say this before, they're all usually mixed in, but tests usually belong in their own folder. It's a source folder, and it's typically pretty much always named test, and then it kind of sits there, friends with source. So you got source and test, and this is where you put your tests. The other thing about tests is JUnit is the naming convention is you put test at the beginning, or is it the end? You put the test at the end of the name, so so that I can match these things. I've got the extra random test. Let's go with that. Okay, here's a test. Let's run it. Red bar, sadness. Okay. Now, this is an interesting thing. I'm going to have to run this a whole bunch of times to make sure that I'm getting all of the letters. The first thing I'm going to test is make sure we can get an A. Make sure we can get a Z. For getting those, let's, So I'm going to have to collect these things, and I'm going to collect them in a string buffer. Letters. A string buffer is a thing that can collect strings. I'm going to append my next letter. Extra random, what did I do wrong there? Does it need to be imported? Yes. So let's just put that in for me. I'm using the short keys there. You guys should get used to the short keys. That was Control-Shift-O for automatically importing your things. Oh yeah, that's good. It would need to be public. Thank you, Eclipse. Okay, and we'll be doing that a number of times. A zillion. Okay, appending all those things, and just for kicks to know that I'm doing something not totally nuts, I'm just going to look at that. Alright, look at that. There it is. Oh, sorry about that, guys. The girls gotta eat. So where were we? Alright, so I'm trying to figure out if I can test to make sure we get an A, and I'm going to do that with an assert. This guy is going to happen down here. Okay, so asserts are what we were using before, and in this case, I'm not comparing two things. I just want to see if it's true or not, so I'm going to use assert true. And then what I want to know is, does letters contain A? Okay, there's no contains actually in string, and the next exercise for you guys is going to be to implement this. We got to do this index of, and that will give us the location of the A if it finds it. Okay, because this is a string buffer, first I have to convert it to a string so that I can do the index of. Oops, what happened there, people? There, okay, and now I want to know if the index that it's founded at is 0. So if it didn't find the letter, it always gives you a -1. That's kind of a typical thing in programming all languages. Okay. So this should say, if I've got an A, that should be true. Okay, let's see. Okay, so after running this 10,000 times, it looked like we got an A. Sometimes I like to see these things break just for kicks. Shouldn't get an A every time. Okay, nice. And I'm going to make sure we get a Z. And I feel like we have converted that to code, so you guys can go. Z, Z, Z. Okay, so we have an error here, and it's not very explicative, so I'm not sure if I showed you guys this before, but you should really be putting little comments in here so that you know why your test failed. Let's colloquial way of saying it. I guess I could make it in programming language like next letter does not return any A's. Okay, look, we never get a Z. I think that makes more sense to me anyways. We're never getting a Z. Something is wrong. So if you're working on these things, I like to split them sometimes. You can split them that way, you can split them sideways. I prefer them to be sideways. Of course, it probably won't do it now because I'm recording. There we go. And I just want, okay, cool. So the test is over here. I'm kind of more working on that one, so I want that guy over there and that guy over there. There's definitely a sort of black magic to this, getting it to drag around to the right place. Thank you. All right. Don't need quite as much over there. I want to see my stuff. Okay. Focus. All right. Sometimes I just need to get back to where I'm at. One of the brilliant things is about having this bar is it keeps you absolutely laser focused on the one thing that you're doing. So it's easy to stay in flow. You're not going to you're not going to miss the fact that this is red and you want to make it green. All right, so I'm going to make it green. How am I going to do that? Well, over here something's wrong. I think the indexing is probably off if it's getting the A and not the Z. Let's see if it gets the Y. Y is fine. Okay, so it's one under, I think. You know, I could think about this stuff or I could just jam that in there. It's not really the object of this particular exercise. Oh, it's green. All right, cool. So I guess this index was off. But now I'm a little worried that it's going to go to the to the other side of the A. The other side of the A is, you know, you have all these weird characters and then you get the ABC. So I want to actually also make sure that, I'm going to just pseudocode it for a second. Make sure that the letter falls after A and before Z. Okay, so to do that, I'm going to have to inspect this guy and I'm going to pull this out as a local variable. This is a refactoring. This is cool. I would usually use my short keys, but I want you guys to see how to do it. You go extract local variable. It even gave me a nice name. Thank you. All right, so all that did was it created that variable so that now I can do something with it because I'm going to do an assert here. It's going to be another assert true. What I want to do is the next letter greater than or equal to A? Jars are cool like this. You can check their numerical value, so that should tell me if it comes after A. Let's try that. Yes. Alright, so it might be fine, but I kind of feel good to have these tests anyway. Just like to see it fail sometimes because that's less than Z. Okay, or sorry, greater than Z. This should be the other way around. So greater than A and less than Z. Okay, I guess it's okay, but I do feel a little better that my test is a whole lot more thorough. Get rid of all that printouts. And yeah, so I guess we have made our next letter method, and I feel like we could give this out to the world now. We could, you know, commit it to the Java open source library because it's got a test and you feel pretty comfortable. You're not going to get people going, hey, what'd you do? Well, you ruined all my code. All right, so the reason that I'm actually showing you all this stuff is because we're talking about extending. We're talking about inheritance, and this extra random has got all of the methods of random. I'm just going to inspect it here and show you what the hierarchy looks like. Okay, so random has all of this stuff, which we want to have in our extra random class. But then we added this next letter class. The main method really shouldn't be there. It doesn't belong there. That was just to get things up and running. And so now I can do stuff like, if I wanted to, have an extra random, not an extra random test, a new extra random, which obviously I need to import. Extra random. Okay, So I could do char, next letter, and then I could also do like int, and then I could still use the existing methods that are part of random. Okay, so what I've done there is I've extended the functionality of the random class. I'm going to try and draw you a picture of what I just did with that better random. Draw.io. So I'm going to use this thing called UML, and that is a way for programmers to communicate their ideas to each other. It means Unified Modeling Language. And this draw.io thing has a little section for UML down here. Okay, so I have these little squares that I use to make my classes, and I had two classes that were in play just now. There was random, and then I also had my extra random. And the way in UML you communicate that there's an inheritance relationship is you do this little arrow, and I'll be talking a lot more about it in the next lecture, this UML stuff. You'll just have to, hopefully the tension won't kill you before the next lecture to find out about that. So here this is a class, we've got the name of the class, then the next section is for the fields or the variables, and the next section is for the methods. And I'll start with my extra random because it's easy. I just added one method, and that was called next letter. And in the parentheses it didn't have anything, it didn't have any arguments, and it returned a car. So that's how you define those things in this. This is a class diagram. I'm not going to deal with the fields for the moment, that's just kind of cluttery. But so you know the random class, and there's familiar things in here, like one that we use a lot, like next int. It's got an argument of an int, an optional argument of an int, and it returns an int. So if I were to actually put all of the methods for random in here, well, I probably wouldn't be able to fit on this page. But nonetheless, I'm trying to show you what this kind of relationship looks pictorially, because I'm going to use this for you guys as exercise. Here's the exercise. Okay, extend the Arraylist class to add two methods, pop and print. Okay, so print is pretty obvious. I just want to be able to print an Arraylist directly with a dot before it. And then pop, I'm going to show you a little picture of what pop looks like. So the reason I chose pop is it's a thing that you can do with lists in Python, but you can't do it in Java. So I thought it would be cool if you could make that and add it to your special Arraylist class. Here's a little animation of how pop works. Okay, so what's happening is it's popping off that 7, then it's popping off that 3, it's adding something, then popping off 7. So what pop does is it returns and removes the last item on the list. Okay, print is obvious, I think. For the diagram, let me do this. Let's have a box for Arraylist. And then let's have a box for better Arraylist. Okay, and then the methods that I want you to add are print. Print is not going to take anything in its parentheses, and it's going to return, and it's going to be void. And let's see if this will go in there for me. Yeah, okay. Another method called pop. Okay, it's not going to take any parameters. It's going to return an object. It's a little bit like the method in Arraylist get. So get takes an int because you put the index in there. This is from the last lesson, and it returns an object. So the reason that these guys need to return object is because the Arraylist can have any kind of a thing on there, but it's always common that object is the root of all objects. So if I was to draw a full thing here, well, actually there's more to it than that, but object is the mother of all objects. Objects is very important. It's like the mother nature of Java. Omnipresent. Woo. Okay, so Arraylist extends object, and better Arraylist. Better Arraylist extends Arraylist. Go over there, go over there. Ooh, well, these are a little janky, but if you guys, it's always, everything's janky when you're making videos and talking at the same time. Okay, so I'm going to show you in the Javadoc. So Javadoc, you've probably already figured this out. But Javadoc is like the online manual for Java. So I'm going to just pull up the Javadoc for Arraylist so we can have a look-see. Okay, this is Arraylist. Here are all the methods for Arraylist. Quite a few. I want to draw your attention to this part at the top. This is showing you the hierarchy. So object is in top, and then we have abstract collection, abstract list. This abstract word will make sense in later lecture, in later lessons. So Arraylist extends abstract list extends an abstract collection extends object. And if you go in there, you can see that. See? Extends object. Okay, but I just want to look at Arraylist for the moment. So we have a bunch of methods in here that are already existing. For your better Arraylist, I would like it to have all these methods and then to add these extra 2 methods. So that's your puzzle. What else do I want to say about this? I think I still want to keep talking about this mama object because she's rather important. And show you it in a different way. So in Eclipse, you can do this thing where you can view the type hierarchy, kind of like I was doing on the Javadoc right there. And so here, this is my hierarchy. It says that extra random extends from random, random extends from object. And here it's showing me that next letter is the method that's in extra random. The methods for random are here. There's a lot of those because you can, we know about these ones, next int and next double and all that. But you can also get like a double stream of doubles if you wanted to. Anyway, that's a bit of a segue, but so those are all the methods that are in random, and then here are the methods that are in object. Every object has these methods. Okay, so I want to explain some terminology of things related to methods that begin with O. Okay, so I'm going to talk about overloading, and I'm going to talk about overriding methods. This will be a really quick intro. Okay, so an overloaded method is this. So here's my array list, and sometimes you'll see, it might be a bit weird, but you'll see a method that has the same name as another method. Here I have an add all, and it's got the same name, but its parameters are different. So here this add all just takes a collection that will be added on to the end of the list, and this add all has an index, so that means it will put the collection at a certain place in the list. Okay, so those are overloaded. So an overloaded method has the same name, different parameters. Those are sometimes called arguments. And then may have different return type, which that is outside of the scope of this lesson. But they also usually do the same thing. That's why, if they have the same name, it would be kind of weird if they had the same name and then you had them do some completely different things. But it's not required by the language that they do the same thing. It's just kind of, normal. Okay, now overriding methods. This is related to inheritance, and we've seen this before in our duck class. So here I have my duck, and this is way back in lesson 5, but we overrode the toString method. See here it says override. And the reason we did that was so that when we printed it, we would see all these nice details about the duck. I think I'm going to do this again because just, well, I don't even remember that stuff. How should you guys remember? Okay, so I'm just going to, like, say print my class here, extra random. And when I print it, I get a bunch of stuff down here. Now that's bugging me because I don't like things to be read if it's not an error. Okay, so we have, this is printing out some stuff about this extra random class, this particular instance actually, and it's telling me that it's in the examples package. That's useful. And then it's got a bunch of gobbledygook over here. So if I wanted to have something else print out, I could override the toString method. So I'm going to override the toString method that's part of object. Okay, that's done that super quick for me. So what I did was I just did toString and then control space, and it was the first option it gave me. So it says there, override method in object. So I'm not lying. And instead of doing the super toString, which is just going to give me the default and this junk down here, I'm going to have it return an actual string, like Jason sucks. That's my boyfriend that dumped me yesterday. And then when I run it, now it says Jason sucks. So sorry to get distracted by my personal things here, but what is going on is the extra random has overridden the toString method, and now when I run it, I get something else. So it's actually calling the one inside here. And that might seem pretty crazy and weird if it's the first time you're seeing it, but I will be talking about it more in lesson 3. And that's what we call overriding. So overriding methods are methods that have the same name. Actually, they have the same everything. Okay, I'm going to explain that better next. Not the next lesson, I'm going to talk about UML, but then after that, I'll be talking about that a ton. But for now, I just want you to know that there are these two things, overriding, overloading. They sound kind of similar. They're both related to methods, a little bit confusing, but there's a little intro to it, and hopefully it'll be clear by the end of this lesson. Okay, so your task is to do that Arraylist exercise. So extend it, and then if you're feeling adventurous, you could write a unit test. I love unit tests. And then you could, and if you're a little more daring, and you have some time, implement an insert method. Okay, good luck with that. See you again soon.